there. In this video, we are going to learn some of the case studies of using system dynamics in real life. Using these case studies, we will get a preview of some of the tools and techniques that system dynamics has to offer. And we will go through each of these wonderful case studies in detail. So let's get into it. The first one is when General Motors in the 1990s and other major car companies, but starting with General Motors, they found out that there are these big superstores like CarMax who are having a huge inventory of almost brand new used cars. So you could say secondhand used cars. And that had an impact on their production because the demand was slowly going down. And so they were trying to find out what's causing this. So before they were able to discover that it was the leasing industry or the CarMax superstore that's causing some of these things, they actually got a team together and got some hypotheses. Some of them were thinking of the Japanese car imports, which were impacting the sales because they were of much better quality, and it took a long time before they got bad. But there was no real evidence. So what they did is they put together a team to understand what's going on. So they came up with this detailed diagram. It shows that when a car gets into production line and before it gets added to the inventory, it has this dependency on inventory of those cars in the system. So there's this whole production control feedback loop, and there's some delay. By the time a new car gets built and more new orders are taken, the company takes a poll on how is the inventory? Are we selling as much as are we producing? And is there more demand? And so the new cars are sold at certain rate from the inventory. But then there is this big new box of late car models that was added new to the learnings for the executives as to how are these late model used cars impacting the sales of the new cars. So basically a new car is either sold based on the decision the buyer makes on the trade-in value of the used car. So a late model new car on the road will only be sold based on some of the decision loops that consumers are going through. So the big thing that they found out is that there's this leasing agreement that the company had come up with, which the superstores were using. And when you lease a car, you don't have to pay as much as the money as you have to buy it off. And you can also trade in a few years if the car value goes down for whatever reason or it doesn't work, you trade it in. So there was this leasing loop, and there was also this pricing game. If the used car was available in the markets and it was lower price, and if its attractiveness was much higher than the relative attractiveness of the new car, then people would tend to buy the old car. So there was this purchase option of the used car that had an impact on the sales of the new car. And the used car market had a huge impact on the sales of the new car. And so depending on the quality of the car and the pricing structure and the leasing agreements and the amount of inventory, the decision would change dynamically. So think about all of these systems that are in play when a car needs to get sold. Even the dealers would be under pressure if their inventory stacks up and if they're not selling enough. So there are multiple balancing loops and feedback loops that come into play for a simple car sales dynamic model. And there's aging of both the new car and the old car, and the aging rate, and then eventually scrap rate, and then the car is out of service. So imagine this entire diagram. It's very hard for us to simulate each of this in our mind, but a model like this is a stock and flow diagram. Having a model like this, you could simulate various rates, various agreements, and find out that there's this whole new gray structure, which the leadership team at GM didn't think of before, that was impacting the sales of the new cars. So there were many theories, but only after they started modeling that they found out that there is this leasing agreement terms that the company has come up with that was actually not good for the sales of the new cars or the profitability. So net profit value of net present value of the profit during three different scenarios: recession, stable, and boom time. Using that previous model, the modelers and the team at GM were able to come up with um, various profit conditions for when we have a boom scenario in the economy, and if we give a 2-year lease, then this is the profit scenario, will be net negative. 2 years, in 2 years will be positive, 3 years will be more positive. So what they found out is that the 4-year leasing agreement had the least impact on profits under all three scenarios, and it was much better for the company even if there was a recession. And so what they ended up doing is, using this model, they were able to predict how each of these variables would come at play, and they were able to come up with the profit prediction of the company based on various factors. This gave them an insight that we should change all of our leasing terms and move people from 2 years, 3 years to 4 years, and eventually only offer 4 years leasing agreements. They couldn't come out of the leasing market altogether unilaterally. They would lose a lot of market share. So they had a deep decision to make: short term versus long term. What is good for them? They cannot just come out. But at the same time, there is a huge loss that they're making because of this market. And so after this profit analysis was done, there was this diagram that was put together by those team of people at GM. It was a pretty good metaphor, powerful metaphor that shows that the production backlog can be stopped during recessions or during lack of sales, but the new car substitutes of the old car economy will continue to stock into our inventory, and because of which we'll have to cut more production, and it could have more layoffs issues and a whole host of things. So this analogy helped everyone understand what was the impact of this huge backlog of old cars that are being leased at a shorter term duration. So using this, GM made a policy decision to make those changes to leasing agreements and all of that. And they were actually right when they did some of this in 1990s. In 1992 and 94, the stock of inventory of these old cars shot up and the price also shot up. GM didn't have to suffer as big of a loss, but many other manufacturers during the same time had a huge loss that they had to suffer. This is a fantastic example in which the team at GM were able to calibrate the impact of these new variables, of new changes in the economy, specifically the superstore, as to how it impacts their business, how it impacts their long-term profitability, what are all the variables at play, how can you use system dynamics and modeling techniques to actually predict profitability under various scenarios, and use metaphors as powerful tools to explain to people how this would be a big impact to them. And they were able to balance out the short-term versus the long-term incentives. It was very clear that the long-term incentives were misaligned. So everyone started modeling based on used car industry inventory as well. So that was case study 1. Let's get into the case study number 2. Case study number 2 is the United States Navy, which had a big order of a huge set of ships to be ordered, and they wanted, the delivery on time and under budget. This is a case study which we will understand how customer interference has a huge impact in delivery. Similarly, in your team, there will be people who are actually doing the work, and there'll be people who will interfere or change their requirements. So this helps us model what is the actual true cost of interference, especially when there is a huge set of dependencies in work that you're doing. So this is also related to product management and project management specifically, as to how you deliver new things. So there are 3 big variables in any project management: people, their productivity, and the quality of the work that they do. So the work that's being done happens, and this is the stock work being done, the work that has to be done. moves into work being done, and it's actually getting done. So these are the three steps. It starts from the backlog, actual work, and to the finished state. Once it's finished, you realize that if it's too late from the time you'd originally imagined that product need, you will find it's already obsolete. So because the customer changes their requirements, or for whatever reason, there's some decay in all the new work that you do, especially if there is a delay from the time you imagined that new product to the time you deliver that new product. So let's imagine that there is some sort of a obsolescence rate. So certain amount of work gets obsolete. And so that work needs to be now removed. So there is some known amount of rework. At the same time, there is this undiscovered rework. This happens because of interference from your customers or your clients. And that has an impact on the known rework as well. So the work being done, the backlog of work to be done increases because of this rework. So it's impossible almost to deliver a project on time and under budget if there is constant interference. This is a very good case study in which we understand the impact of being agile and when you need to be agile versus how strictly you need to finish certain big deliverables. It's very important to be agile, but this will tell us how much impact it may have. So the company that took this order from US Navy found out very quickly that they are incurring huge cost overruns because of rework, because of new changes, and they wanted to get at least close to around $500 million more from the US Navy, saying, hey, this is expensive. We need to rework our contract. The US Navy was just not ready to say, hey, this doesn't make sense. And so what they did was the company made this detailed mental model into a system business dynamics model or stock and flow diagram. They expanded their simple model, and then they also found out that rework had a huge impact on people's productivity, their fatigueness, their burnout rate. They had to work overtime. Even their hiring had a huge issue. So there was direct impact of known rework, but there was a lot of these indirect impact of known rework. So they created a model and simulated various impacts and costs of this new work that was being added because of customer interference. Though when customer changes their requirement, it has a huge impact on your team because they just did something and now they have to redo it. So they eventually burn out. They eventually lose faith in the system and then they leave. And so then you have to hire new people, and projects tend to be behind. And so when projects are behind, you have to pay charges. In certain cases like the US Navy, you have to pay charges on a daily basis. So what happens is management comes in and then they schedule an acceleration of the work so that the timeline is actually met. And so what happens is out of sequence work gets done that should have been done in sequence. There's congestion at work site. People are stopping on each other. There's coordination problems, morale problems, whole host of things. Each of these things have a huge impact on the work really being done. These are indirect impacts. And so this model was able to articulate the cost of indirect impact on the project in money terms. And when that happened, it was able to prove in court that there was a huge change in contract that was needed for the money to be paid, and also timeline. This is another case study which I think we can use for modeling as to there is a significant impact on direct rework and indirect impacts of people, morale, skill sets, hiring, acceleration issues that have on your system. So be very mindful on this agility part and use it very carefully when you absolutely have to. That was case study number 2. Let's get into case study number 3, final one. This is the case study where we will see this game that DuPont had been playing for a long period of time, where they were constantly under maintenance. The senior manager DuPont found out that their plant was being less up, so the uptime was low, but at the same time, compared to the industry average, the amount of money spent was much higher than the industry for maintenance. Why was the plant less up? It should have been more up. So the uptime should have been better, the reliability should have been better, but it was actually bad. So what they found out was, this is a case study where we will see that certain cultures around, certain toxic cultures get set up where there's this maintenance nightmare that is encouraged without conscious decisions, because defects get generated into the plant, and if they are not proactively eliminated, then the defects go up and maintenance goes up. So what was happening was, a defect leads to a breakdown, and a breakdown has an impact on the uptime, and it causes repair expenses. So now maintenance becomes reactive because it was not proactively scheduled. You pay more charges for expedite delivery, and people are stressed out. People make failures, they make mistakes, parts are more expensive, and so you choose to buy low quality parts, and then cause more defects. So there's this whole maintenance repair loop that is a vicious cycle. Similarly, the uptime goes down, maintenance goes up. But at the same time, if there was a way in which the maintenance eventually went down, how could we get there was the question of this case study. So what they did is they used system dynamics to model the system. There's a constant rate of defect creation, which was easy for the senior manager to know from talking to various leaders. And these defects of the equipments causes some sort of a takedown rate. You have to take those plant down, and that causes an uptime issue on the plant. And there is a maintenance loop where you do the maintenance. And so once you maintain and do the fixes, the defects are eliminated. And there is a constant rate in which there is a breakdown of various instruments. There's a known lifetime for a given part, and so you need to maintain it. You have to maintain it proactively. But what they found out was that they were maintaining it only reactively, only when it broke down when they came in. And so they paid a lot of costs because they were doing reactive maintenance. They were investing less in planned maintenance. And so the time to fix those issues went up. Cost went up because it was all last minute reactive ordering, expedite delivery. Part qualities suffered because costs were so high, so decisions were being made to use lower quality parts, etc. So they created this model in which there was these various systems at play: proactive planned maintenance, reactive maintenance, and defect elimination through proactive maintenance and through repair. So there are two different flows in which a defect is fixed either through proactive elimination or reactive maintenance. And with this, they were able to find out that even why they were spending more money. They were spending more money because it was all reactive. And they found out that this culture of maintenance was just business as usual. So there were many detailed things that they did to go deeper into why this reactive maintenance was happening. They found out that because of pressure in cost savings and uptime, pressure to cut cost had an issue on the part quality. Pressure to cut cost had an issue on improvement effort. It was made as minimum as possible. Pressure to cut cost had an impact on the training of the people. Pressure to cut cost had an impact on plant scalability maintenance because it was just viewed as nice to have. So when there was this pressure to cut costs because of low uptime, it actually caused a vicious cycle. And so then there was this reactive cycle that made the maintenance even bad. And so this was all started with this loop of maintenance costs, which was going up. And so they had a huge pressure to cut costs, and when they cut costs, this loop further exaggerated. And so the revenue went down, plant reputation went down, maintenance went up. It was a vicious cycle. So some intervention was needed. So with this modeling, they were able to find out that there is a way in which temporarily, if we take for a year an increase in cost with proactive maintenance, that going forward after there, that we would be in a net positive scenario. So what they found out is they needed 91 people, and they were able to provide 83% uptime at net neutral. That's what they were doing under the current existing policy of reactive maintenance. 91 people, 83% uptime, 83.5. And so then they did scheduled maintenance. They could reduce the headcount and still get the same level of uptime, but it would have a slight improvement. And then they found they could further reduce headcount, and they would continue to do reactive maintenance, but they could do proactive maintenance, and the uptime would still remain the same. And they said, if you want to really maximize the profit, keep the headcounts the same. You can go from 83 to 93, but it'll take a year of down in profits. But afterwards, it was a $9 million run rate in going forward. So this is a case study where we find out that things, most of the times when they are in a vicious cycle, they actually get worse before they get better. And what they did with this case study was, it was very hard for them to make a case that it's going to actually get worse for a few months before it's going to get better. So they created a white paper with various findings. They presented it to various people at various leadership levels. They even created a game to simulate this entire process where people could get involved. Hundreds of thousands of people were educated, and they were evangelizing this in a big way. And they were able to get a critical mass of people once they were able to get all of them to work together. As you can imagine, there are many people at play here, and all of them, the operations maintenance people has to work with the plant maintenance people to the plant manager, because the plant manager would not give up the ability to take down the plants for proactive maintenance. But if they played this game and if they were all bought in, then it was easy for them to make a case. So creating detailed documents, presenting your case for the modeling, making everyone involved, evangelizing your work, building a critical mass is an important thing in terms of various steps when you come up with these new models and come up with how to make change in policy. And remember, it often gets worse before it gets better. So there are many learnings in these 3 case studies that I have from reading the second chapter. And the biggest one is the greatest potential improvement comes when the modeling process changes deeply held mental beliefs. So these 3 big case studies are basically trying to get to a better future. But a better future only comes when the inner mental model that we all have, the entire company has, changes. And you can only change and influence a person's mental model by using data, by using modeling, by incorporating their feedback, empowering all of their criticism into the model and using the model as a standard, and eventually involving them through games, playing games of simulation. Second big thing, empowering your clients to discover insights themselves. If you tell someone that it's going to get worse before it's going to get better, it's very hard for them to believe. But if you get them to play a game and have them discover that insight for themselves, there's nothing better than that. If you want to, let them reach their own conclusions, empower them, give them the tools so that they can reach their own conclusions. It's very critical. And remember, you need to not only speak to their heads when you have to convince them or you want to influence them, you have to also speak to their hearts. And you can only do that if they themselves feel it as well. So remember, all of these case studies are good, but you'll be criticized in a pretty big way. You will say, hey, these models were developed just for proving your point, and this doesn't take care of these 10 different things. It's going to make it impossible for you. So remember those steps. System dynamics helps us model long-term consequences of our actions. All of these models that we looked at, it's so hard to keep everything in our mind. And so it's hard to believe how each of these things will play out, right? So only with certain tools and techniques that we can guarantee ourselves what will be the long-term consequences of each of these factors moving up or down. So modeling is very important, but also knowing that the tools that we use on a day-to-day basis have their own place and they should be used. But this complex system can be improved and can be learned and changed by using system dynamics, especially when you're thinking of the long-term consequence. Next, real people change belief, change focus, agree on something new. Critical mass buildup is essential. Things get worse before it gets better. So we went through this in the earlier slide. You have to involve people. You have to, if you were to change belief, it's a long-term process, not a short-term process. You have to get them to build consensus. You have to build that critical mass. Solve a particular problem by focusing on what the client's problems are. Don't model the entire system and iterate. So focus on a specific problem. We went through the problem of cost for DuPont, maintenance cost. And then we went through for the Navy, this on-time delivery piece. And then we went through the first one, which was leasing agreements. A specific problem. And iterate with a simple model first. Start modeling early. And encourage criticism early. Learn quickly. Embed your stakeholders in your project, especially if you're modeling for change. Don't use system dynamics as a standalone tool. You should be using tools for various things that you use, but this is, if you want to model a complex system, then system dynamics is helpful on top of all the tools that you use on a day-to-day basis. And the biggest one is get a primary simple model working fast and iterate on it. Use expert modelers. They have a lot of experience that can be used, and focus mainly on capturing most of the feedbacks, especially those that have delays. Implementation is a long-term process, and change is a long-term process in personal, organizational, and social change. So be patient, be consistent, improve your model, and stick to it. All the credit goes to John Sterman. Love this book. I only covered less than 1% of what I've learned from this book. Highly encourage you to read this book to get better at systems thinking and use some of these techniques in your day-to-day life when you work on a new project, when requirements change, when you have to model changes for the long term. Then you can actually have a competing strategy against any kind of work that you do. All right, thanks.